Okay, it's week 4, and I have some good news, and I have some good news. The good news is that we've only got one more week to go until Rag Week, which is where everyone wants to be. And the other good news is that this week is really quite short and quick and sharp. And yeah, it's definitely going to be easier than the last 2 weeks. So prepare for interesting, quick, fun week and then Rag Week. And don't skip this week because it's quick and fun and we'll get to Rag Week really fast. Okay, let's get started. Okay, so today we are going to be talking about the most important question that we will cover on this course, which is the best LLM? That's the one that you'll be able to answer at the end of today. And what you can already do is confidently code with frontier models with the Chat Completions API, build a multimodal AI assistant, and build solutions with the Hugging Face Transformers library, both at the pipelines level and at the tokenizers and models level. Okay, let's talk quickly about how we got to where we are. You started out, just a few weeks ago. We covered the foundations, the Chat Completions API. We covered frontier models APIs, tool calling, multimodality. And then last week, we really dug into Hugging Face. This week, selecting models and also generating code. And then next week is Rag Week. Did I mention that next week is Rag Week? I might have mentioned that next week is Rag Week. We will do that next week. It's going to be so great. And then the week after that, we go, the last 3 weeks are really intense. Fine-tuning a frontier model, traditional data science and modeling, and then fine-tuning an open source model, a really big week, and then the finale, agentic AI, a beautiful product, modal.com, so much to do, at the end of which you will be able to plant a flag of success and say that you have mastered LLM engineering. And this brings us to the question du jour, which is the best model? What's the best LLM to pick? And I know you've been wondering this, and of course the answer is that is not an acceptable question. It's an ill-posed question. There is no best LLM. The right question is, what's the right model for the task at hand? Given the problem you're trying to solve, which is the best model for that? And in answering that question, there's a whole strategy that we're going to cover for how you go about making sure you pick the right one. And of course, it starts with understanding your requirements. And once you've understood the requirements that we will cover later, you then look at a model in 2 ways. You look at 2 aspects. One is just the basic information about a model, and the second is digging into the benchmarks. And when I say looking at the basics, I'm saying things like how many parameters does it have? What's the context window? How much does it cost? What's the license? That kind of stuff. You first use that to develop your candidate set of models that you want to look in more detail at. The ones that you can afford, the ones that you can build against quick enough, all that kind of stuff. And once you've done that, the next thing you do is you look at the benchmarks. And the benchmarks are the published metrics in which the models are assessed against different things, like how good are they at coding? How good are they at understanding language, at reasoning? Those benchmarks. And you can look at them on leaderboards, which are the sort of tables which rank the different models against different criteria. And there are also arenas where models are put head to head, which are some fun places to look. And we will look at all of this over the next couple of days. But first, let's drill into the basics. So what do I mean by looking at the basics? Well, first of all, you'd want to look at the models that you're thinking about and say, are they open source or closed source, paid models? Are they chat or are they reasoning models or are they hybrid? And you've now got a pretty good sense of what that means and the pros and cons. But certainly, it's not always the case that a reasoning model is better. Reasoning models often perform better on benchmarks. They often perform better in terms of their intelligence because they can think things through, and that's one of the 2 ways you can scale. But they tend to be slower. They tend to not be so good at generating creative content. So there are definitely limitations with reasoning models as well. And then there are hybrid models, which are able to choose whether they want to chat or do reasoning, depending on the situation. And often that's a great choice, but sometimes you don't want a hybrid model because you only want a chat model, for example. So that's one decision. There's also the date when the model was released, of course. How recent is it? When is its knowledge cut off? When is the time up until it was trained? That will tell you what kind of information is part of its training set that it will already know without needing any inference time techniques. In other words, if it was trained up until July of this year, then built into its training knowledge already will be facts up until that point. It will know about all that information just right away out of the box. You can just ask it that question. But if you wanted to know about more recent information, you would need to add that to the prompts. You would need to arm it with that information when you ask it the question so that it's equipped to answer it, either through prompts or through tools. And when I say inference time techniques, that's what I mean. You would need to come up with ways to inject that expertise into the model. Okay, then of course the number of parameters that gives you this indication of its capability of how much information it's been able to absorb during training time, and we went through that timeline of how many parameters there are in larger models, and of course I did point out that sometimes it can be a mistake to over focus on the number of parameters, because in recent days people have done well at getting more into slightly smaller models, but as a rule of thumb, generally bigger is better. More parameters means smarter. And then the training tokens is just how much data was used to train this model. More data, of course, means it's got more knowledge. So that's something to look for. And the context window, you know this one well. This, of course, is the total capacity the model has to look back on information from the conversation. It's not just the most recent prompt. It's not just the current prompt it's responding to. It's got to fit the first message you sent it, the reply, the next message, the reply to that, everything that's going in this memory of prior conversation, of prior messages as part of this conversation, up to and including the current response that the model is generating. It all has to fit into the context window. Yes, I know you understand this. So that's another thing to look for. And typically you can get all this information by looking at something called the model card, which is something that every provider like OpenAI publishes with its model. So you can just Google just to look up the model card. But there are also some leaderboards which lay out this information so that you can compare it. And then there are some other basic facts about models that you'd want to know to be able to compare them. And some of these aren't available on the model card. You'd have to look them up. One of them, of course, is the cost. How much is it going to cost to run this model? And there's two possible costs there. It could be the API cost if you're using like a cloud, a frontier model in the cloud, or if you're running it locally, there's this sort of sense that if I'm running a local model, then it's free. And in a way it is. But remember, you're still paying for the compute one way or another. If it's running on your machine, it's going to be hammering your computer. If you're running it on your company's servers, it's still got a cost. So you have to factor in the runtime compute. There's the cost to do any extra training that you need to do. So if you're assuming you're going to take this model and you're going to need to train it more, as we will do in week 7, and it's going to be great, then you need to factor in that cost. If you're going to be building something like RAG that we're doing next week, or building a product around it, then you need to understand the build cost. And that's something that you'll need to work out. And then very much related to build cost is the time to market, which is, of course, how long is it going to take you to build the product that you need to build? And you might say, what's that got to do with the model? Well, these things are all related, because if you're using something simple, like if you're using GPT-5 or Claude 4.5 Sonnet, then you know you're getting such a head start that the amount of build you have to do is relatively light. You can very quickly roll something out that's using a top frontier model like that. But if you're trying to use your own open source model, or if you're wanting to use a smaller model, a cheaper model, your runtime costs will be lower, but you'll need to spend more time doing the build and experiments and figuring out how you get the business performance you need from a smaller, cheaper model. And so that would affect the time to market. So that is absolutely a factor here. The larger, more expensive models, you should be able to get out much faster. Rate limits is a factor. So some frontier models, some closed source models have limitations on how often you can call them. And so you need to make sure you're cognizant of them. Typically, if you're willing to pay more, then you can have higher rate limits. So there's usually an opportunity to spend more money there, but not always. Even OpenAI has limitations. Even if you spend to the top tier, there are some limits. Although I imagine there's a call me at some point that you could probably have an enterprise deal if you wished. Still, you need to know about what the constraints are. And then speed, how fast the model will respond. Different models have very, very different speed characteristics, as we'll see later. But things like for Gemini, Flash Lite is blazingly fast. GPT-5 Nano is quite fast. GPT-4 Nano is really fast. and it's great to have that perspective on these things. And of course, yes, there are leaderboards that compare these so you can quickly pick the model that's going to have the performance characteristics that you need. And then closely related to speed is latency, or people sometimes talk about the mean time to the first token. And it's particularly prominent with the reasoning models that tend to think before they start responding. So the time until it starts bringing back responses that you might be streaming onto your UI, that has become increasingly important. And so people need to look at both speed and latency, or the time to the first token, side by side when considering whether a model is suitable for their business purpose. And then license, often forgotten about, but particularly when you're working with open source models, different models do have different licenses. You need to understand some of them are very permissive and you can use them for any purpose. Some of them have limitations in terms of your ability to use it for commercial gain. So there's some revenue caps. And then some of them, like Meta's, need you to sign various agreements, as you've discovered, which limits your ability to use them for evil and things like that. And also, I think, perhaps to compete with Meta. But of course, that's where you get the lawyers involved and you make sure that whatever license is associated with a model suits your business goals.